Hello everyone, myself Snehar. I am from 4th SEM CSC department of SVCE, Bangalore. Today we are going to see about selection sort. Welcome to our presentation on selection sort, one of the most fundamental sorting algorithms in computer science. Sorting algorithms are essential tools for organizing and analyzing data, and selection sort is an important member of this family. In this presentation, we'll explore the inner workings of selection sort, its time and space complexity, advantages and disadvantages, as well as common mistakes and optimizations. By the end of this presentation, you will have a solid understanding of how selection sort works and why it is so important in sorting algorithms. Sorting algorithms. Sorting algorithms are essential part of computer science and data analysis. They are used to organize data in a specific order, making it easier to search and analyze. There are many different types of sorting algorithms, each with their own strengths and weaknesses. For example, bubble sort is a simple algorithm that compares adjacent elements and swaps them if they are in wrong order. While it is easy to understand and implement, it's not very efficient for large datasets. In contrast, quicksort is more complex algorithm that use divide and conquer to sort data quickly, but it can be difficult to implement correctly. Selection sort. Selection sort is a simple sorting algorithm that works by repeatedly finding the minimum element from an unsorted list and placing it at the beginning of the list. This process is repeated for the remaining elements until the entire list is sorted. Although selection sort is not most efficient sorting algorithm, it is easy to understand and implement in Java. Let's see how does selection sort work. Selection sort is a simple sorting algorithm that works by selecting the smallest element from an unsorted list and moving it to the beginning of the list. This process is repeated until all the elements are sorted. The algorithms of selection sort can be broken down into two main steps. First, we find the smallest element in the unsorted part of the list and swap it with the first element. Then we repeat this process for the remaining unsorted part of the list until all the elements are sorted. In Java, this can be implemented using nested loops and be min index variable to keep track of the smallest element. Selection sort code in Java. Below code is a sample code for selection sort in Java. Selection sort example. Let's take some array of integers like 5, 2, 8, 3, 9, 1. We'll use selection sort to sort this array in ascending order. First, we find the smallest element in array and swap it with the first element. In this case, the smallest element is 1. So, we swap it with the 5. The array now looks like this, like 1, 2, 8, 3, 9 and 5. Time complexity of selection sort. The time complexity of selection sort is O of n power 2, which means that the number of operations required to sort a list grows exponentially with the size of its list. This makes selection sort inefficient for large lists as it can take long time to complete. Compared to other sorting algorithms like quicksort and merge sort, selection sort has higher time complexity and is generally slower. However, selection sort can be useful for smaller lists or in situations where memory usage is a concern. Now let's see space complexity. Space complexity refers to the amount of memory required by an algorithm to solve a problem. In selection sort, the space complexity is O of 1 because only a constant amount of additional memory is needed to store temporary variables and swap elements. This makes it a good choice for sorting small arrays of lists with a limited memory resources. Compared to other sorting algorithms, selection sort has a relatively low space complexity. For example, merge sort and quicksort have a space complexity of O of n, which means they require additional memory proportional to the size of input array. This can be a disadvantage in situations where memory is limited. Now let's see advantages of selection sort. One of the main advantages of selection sort is it's simple to understand and implement. Unlike other sorting algorithms such as quicksort or merge sort, selection sort does not require complex data structures or recursion. This makes it a good choice for small data sets or when simplicity is preferred over speed. Another advantages of selection sort is that it's an in-place algorithm, meaning that it does not require extra memory to perform the sort. This can be useful in situations where memory is limited or when working with large data sets. If we move forward, we'll see disadvantages of selection sort. One of the main disadvantages of selection sort is its time complexity. Selection sort has a time complexity of O of n power 2, which means it can take long time to sort large data sets. This makes selection sort inefficient for sorting large amounts of data. Another limitations of selection sort is that it's not stable. This means that the order of the equal elements in the input list may not be preserved in the output list. This can be a problem in some applications where the other order of equal element matters. Let's see real world applications of selection sort. Selection sort is commonly used in computer science and has many real world applications. One example of its use in select sorting of data in spreadsheets. When a user needs to sort a large amount of data, selection sort can be used to quickly and efficiently organize the information. Another example of selection sort's real world application is in the sorting of search results on a popular website. When a user searches for something on a website like Amazon or Google, the search results are often sorted using selection sort to ensure that the most relevant result appear at the top of the page. Now conclusion. In conclusion, selection sort is a simple yet effective sorting algorithm that works by repeatedly finding the minimum element from an unsorted array and placing it at the beginning. It has time complexity of O of n power 2, which may not ideal for large data sets, but it is easy to implement and understand in Java. It's important to understand the algorithm of selection sort and its implementation in Java, as it forms the basic for more complex sorting algorithms. By mastering selection sort, one can easily move on to more advanced sorting techniques such as merge sort and quick sort. Thank you for watching my video.